Section 2.2 is linear functions and modeling. So in this video, I'm going to teach you how to use Desmos to model your data. So over here, I have a table that is temperature versus ice cream sales. So the x coordinates are temperature in Fahrenheit, and the y coordinates are ice cream sales in dollars. So what I'm going to do is over here, I have Desmos open. So we want to create a table. So you're going to go up to the plus sign and add a table. Your X's are the temperature data and your Y's are the ice cream data. So you just type it in 85, and then you can tap over and you go 200. If you want to go to the next one, you tap down. Just be careful on your phone. There's this powered by Desmos right underneath, and if you click on it, it'll take you to your home page and delete all your information. Try not to click on it. You can always hit the next button and it'll take you over. So you just continue on and type in all your data. So now that we have all our data in our table, we can't see the coordinates currently. So if you go up here to the wrench, we can change our x and y axes. We can scale it. So over here, our x-axis, our smallest x coordinate is 66. So I'm going to set this to be 60. And our largest x coordinate is 91, so I'm going to go up to 95. Our smallest y coordinate is 100, so I'm going to go 90. And our largest y coordinate is 230, so I'm going to go up to 250. And now we can see all the data points. So now what we want to do is we want to find a line of best fit. So a line of best fit is a line that best represents the given data. We're going to use the slope-intercept form y equals mx plus b to help us with that. So going back over here to Desmos, you're going to go to the plus sign and add an equation, or just tap on the next one. We want to use y equals mx plus b, but a general form of it. So what we're going to do is first we have to tell the calculator, Desmos, that we want it to take our y coordinates from the y1 table that was given. So instead of just typing y, we're going to type y1. If you type the 1, it automatically drops it down into the subscript. Then we want to say it's not exactly equal, but it's close. So we're going to use the tilde. On your phone or on a tablet, you go under the ABC and the tilde is down here at the bottom. Then we need an M for slope. We want to tell it to take the x's from this x1 table. So we're going to do the same thing. We're going to do x1, and then we have to add on our y-intercept of b. So y equals mx, y1 tilde mx1 plus b. And now we have a line of best fit. So this line of best fit best matches the given data, even though there's not a single point that goes through the line. Over here, we're given some information. So they tell you what m is. That would be the equation of the line, or sorry, the slope of the line. So 4.1933 is the slope of that line of best fit. And this is our y-intercept, negative 163.41. That's the y-intercept for the line of best fit. So if I asked you to write the equation of the line of best fit, or the progression line, it would be y equals 4.1933x minus 163.41. And that would be the actual equation of the line of best fit. There's another piece of information that this block gives you, and that's this R value here. This R value is what's called your correlation coefficient. So your correlation coefficient is how closely the line of best fit represents the data. If you have a positive R, that means you have a positive slope. So over here we have a positive 0.8, so that's why our slope is going up. And then if you have a negative R, it's a negative slope. The closer to 0 is a bad correlation, and the closer to either 1 or negative 1 is a good correlation. Think percentages. The closer you are to 0, that's a 0% correlation. The closer you are to 1, that's a 100% correlation. So over here we have a 0.838. That's about an 84% correlation. So there's definitely some correlation, but it's not 100%. It's not perfect. We usually say 0.9, 0.95. Really good would be 0.98, 0.99 above, but a 0.83, 0.84, that's telling you, yeah, there's definitely a relationship between how hot it is and how much money people are spending on ice cream. The last part of information you're going to have to know is how to use this. What is the point of modeling data? So the point is not just to be able to create a pretty scatter plot and a line of best fit, but to actually use this data to help us predict something. So the very last part of this is extrapolation, or extrapolating your data. So to extrapolate your data, I kind of consider it, predicting the future. So using the information you're given to predict the future. So if you're given, you have this line, y equals 4.1933x minus 163.41, we can use this to extrapolate or figure something else out. So for instance, a question could say, how much using this information would be spent on ice cream on a day of 100 degrees? So how would we figure that out? Well, if it's 100 degrees, that's our x coordinate, because the temperature was our independent variable, or our x's. So if we wanted to do that, okay, so that means that we want to plug in 100 for x, and then if we calculate this, that would give you how much ice cream would be spent on a day that the temperature was 100 degrees. So if we go over here and figure that out, y equals 4.1933 times 100 minus 163.41. That tells us that about $256 would be spent on ice cream on a day that it was 100 degrees outside. So this is section 2.2, linear functions and modeling.